All right, started. Good morning, everyone. Today is Wednesday, September the 8th. All right, we got bell work. So I'm going to go ahead and just to save time, we will go on just to show the answers. All right, so here's the answers for these 4 questions. How did everyone do on those 4? Checking the answers. Pretty good. Maybe you missed 1 or 2. Just curious, did this one right here throw anybody off? Yeah. So remember, like when you have factors, right? You just have you have a single term factor. Think of it this way: set it equal to 0 and solve. So 2x equals 0. You solve it, you get x equals 0. So that's where that came from. Yeah. So yeah, when in doubt, set it equal to 0 and solve. Okay, and you get 0. Other than that, the rest of them look, that one too, right? You can set it equal to 0, and that's how you get 0. Multiplicity of 3. I say number 11 and 12 may have tricked you on those 2, but other than that, the rest of them should be pretty easy. Yeah, just be careful, and seeing these now, and hopefully you should have seen them in the modules if you did them like you're supposed to, right? All right, so this is day 3 of 1.06, graphing polynomial functions. Now, we kind of did this yesterday, so really today's lesson is more of a recap. It's review over the last few days. So yeah, I have a lot of examples. I'm going to skip a lot of them because there's so many. I will choose the ones that I like. All right, make sure you have your paper, pencil, graphing calculator, Desmos preferably. All right, so given this problem here, now we've been doing this the last few days. All of us here should be able to find the x-intercepts, right? We should be able to find the end behavior. We should be able to find the multiplicities of the roots, like the bell work. And we should be able to find the y-intercept, right, for scaling purposes. How's everyone feeling about this so far? And again, hopefully you've gone through the modules and practiced those examples. There's a lot of examples that I didn't cover in class, I don't have enough time, and that's up to all of you to go through those and work them out. It is required. If you're relying on just coming to live sessions to do well in this class, you might do okay. You will probably pass if you're here every day and actually working these problems out. But yeah, you need to go through those modules and work those examples out for practice. So yeah, these are, should be pretty easy by now, I think, for the most part. And then graphing it, we talked about this, all we're going to do is you plot the points we found, right? We plot the intercepts, the x-intercepts, and even the y-intercept, and use the end behavior to, create our graph, right? And we can use Desmos to verify. So all of these problems that you have to graph or pull any of the stuff out, you always want to graph it in Desmos, right? And in my opinion, it's probably the first thing we should probably do. Makes everything a lot easier. All right, so just quickly just going over this like this. We would go to Desmos, right? We would graph it, we would get this. We can pull out all 3 roots. So we can pull out -3 and we can pull out -1. All right, what is the multiplicity of this 0 right here? Anybody know? What's the multiplicity of that 0? 2. And how do we know it's 2? Well, yeah, it's like what's another way we know it's a 2 other than, yeah, it's a quadratic, sure. Because the u, yeah, it bounces, right? Yeah, it bounces, so it has to be even. It has to be 2, 4, 6, or 8, or so on, right? Yeah, so remember, passing through is odd multiplicity, and then bouncing is even multiplicity. Well, it has to be 2, and that has to be 1 because we have to have a maximum of 3. So there's 2 and there's 1 for a total of 3, right? So given this problem, like on a test or quiz, all of you should be able to pull out the zeros, the y-intercept, determine the multiplicity being, well, 1 right here, which we don't have to actually state, and this one being a 2. We should be able to do all of that. This is a very straightforward, easy problem. All right, calculating roots. So I have these four. Again, this is, remember, today is a lot of review, not necessarily graphing. In the end, we're gonna graph some of them, but I do want to review, get some of these roots, because sometimes finding roots isn't always that straightforward. You know, we really hope, like looking at this, we are expecting 4 solutions. We're expecting 3 solutions. We're expecting 4 solutions, and we're expecting 4 solutions. So that's easy to identify. But finding, like for number 1, finding all 4 solutions may not be that easy, right? Sometimes we run into problems. So let's look at number 1 and let's see if we can find all 4 solutions. Now, here's a challenge for all of you. The 8:30 a.m. class, they were unable to find all 4 on their own without my help. So let's see if you can find all 4. All right, so let's, I'm gonna put 2 minutes on the timer. And I want you, in that 2 minutes, you should be able to find at least 2 of the 4 roots. So after 2 minutes, we'll see which 2 you found first, and then I'll give you more time to do the remaining 2 roots. 2 minutes. All right. All right. What are the first 2 roots everyone found? I don't know if -0 is an answer or even a number, but 0 and -5, Isaiah, will sound pretty good. So, so yeah, we got 0 and positive 5. Or she meant negative 5, sorry. So 0 and negative 5. Enzo says a half might work. This is number 1. There it is. Okay. So I would agree with you that 0 and negative 5 look pretty good. And I did graph it right here. So when you graphed it, everyone get that same thing, right? And we do see it crosses 4 times. So the graph at least tells us all 4 solutions are real. That's a good thing, right? All 4 solutions are real. But out of those 4, only 2 of them were nice numbers, right? So we got 0 and negative 5. So, everyone should have graphed it first. Everyone should have got 0 and negative 5, without much trouble. And then everyone should have done what? So once 0 and negative 5 are solutions, what should we do? What did all of you do? What do you mean take the factored version? And Isaiah, plugging it in, what did that tell you when you plugged it in? Come on, guys. We've been doing this all week long. Last week. So, in other words, how do we approach or how do we find the other 2 zeros? So you're plugging it in. What is plugging in gonna do for us, other than verify that it works? Like, how does that get us to finding the other 2 zeros? Because plugging it in is just going to tell us if it works or not. It's not going to. Yeah, it's not. So just plugging it in doesn't help us find the other 2. It helps us verify the 2 that we already know by graphing. So we already have the y-intercept. It's 0, 0. I think it's pretty clear based on the graph. But so we only have 2 of the 4 zeros. So what path do we take now to help us find the remaining 2? No one saw what Enzo wrote except me. He says, try and factor the answer to the synthetic division. So I understand what you're trying to say. Doesn't really make sense, but I understand what you're trying to say. You're just not using enough words to expand. So what Enzo's trying to say is we use synthetic division to reduce the polynomial. That's what he meant to say. And then he's saying once you reduce it, try to factor that polynomial. Is that what you're trying to say, Enzo? Yeah. So I understand what you're trying to say, but you didn't use enough words. So yeah, guys, we've been doing this yesterday and last week. We should all know that once you graph it, you pull out the ones you do know, and we use synthetic division to reduce the polynomial. We've done this many days. And you should have done this in the module. So to save you the pain of doing something we already know how to do, synthetic division, there it is. There's the work. This not only verifies that we get remainder 0 here, which we do. I didn't put 0 here, but I did there. I don't know why I didn't do it there. But anyway, we reduced it down to x squared minus 11x minus 6. Now, we went over on how to do this, right? Like, is everyone good on synthetic division and reducing it to this polynomial? All right, is everyone good on that? So it is my hope that everyone was able to get to this step without my intervention. So all of you should have got to here. All of us confirm that -5 works and 0 works. And we reduce the polynomial by those two factors. So everyone should be here. Looks like most of you are. So we're at x squared minus 11x minus 6. Now, one way to verify that this actually is correct, if we were to graph this on the same graph as this, so we just created another graph in Desmos with this equation, we know this is correct if it crosses the x-axis at this exact point and at this exact point. So again, if we were to graph this alongside on top of this graph, your parabola, your quadratic, would cross at this point and at this point. If it does, the equation is correct. If when you graph this, if it doesn't cross both of these points, something in your work is wrong. So again, graphing this and it crosses these verifies that your work is correct up to this point. Now, Enzo was saying, once you reduced it, we try to factor this. All right, can we factor this? Can you think of two numbers that add up to -11 and multiply to -6? Is that a possibility? Yeah, it is not. So Enzo, smart young man. So Enzo says, well, we can't factor it, so it looks like we're going to have to go back to 8th grade, 7th grade math, or whatever grade you guys learned the quadratic formula, and we're going to have to solve for x, right, by using the quadratic formula. You could also potentially use completing the square. I probably wouldn't because this is an odd number. If it was even, I would consider it. Because it's odd, I probably would just do quadratic formula like Enzo did. So let me give you the quadratic formula. Now I want everyone here to solve this equation using the quadratic formula. This is 8th grade math. Well, we'll call it 9th grade math because you definitely learned it in Algebra 1 freshman year. So all of you use quadratic formula and solve for x. I'm going to give all of you 2 minutes. All right, what do we get for the other two answers? Yeah, it's not a very even number. You're right. So what is it? Um, yeah, you could have done 11. So I'm going to type it in chat of what I probably would have done. So if this was me, assuming this is right, um, yeah. So Isabella read my mind. Yeah. So Isabella, looks like you got it right. A few others got it right too. Um, 241. It's, yeah. So let's take a look. So you plug it in, right? And we simplify it. And you get down to here. Negative 11, negative 11 becomes positive 11. Negative 11 squared is positive 121. Negative 4 times 1 times negative 6 is positive 24. And then 121 plus 24 is 145. So hopefully on your paper and going forward, you shouldn't type this entire thing in and hit enter in a calculator. Nobody should type this all in. You should work out the parts like I did to show your steps, right? The square root of 145, it does not simplify further because 145 is 5 times 29 and 29 is prime. So it does not go any further than that. So yeah, 11 plus or minus rad 145 all over 2 is the correct answer. So now we have all four. -5, 0, and then these two answers. Now, if you wanted to verify this is correct, if you typed in 11 minus rad 145, hit enter, divide by 2, hit enter again, whatever decimal number you get will be this exact decimal answer right there. So we could verify, right? And then if you type in 11 plus radical 145, hit enter, then divide by 2, enter again, the decimal that you get will match this answer on your graph. And that's how you would verify this answer. Ooh, neat. You did. And so is that what you got before going through this? Nice job. Nice job. So on your test, on quizzes, on TGA, if you gave me a decimal answer right here, I would mark the entire thing wrong, just so you know. I never want to see decimal answers unless explicitly said, or the original problem contained decimals, then it would be appropriate. Yeah, so Enzo, the don't put 11 over 2 and then rad 145 over 2. I think generally speaking, when you enter answers for test quizzes, for like especially quadratic, they want you to write it all over the common. What you wrote is not wrong. I think they want to see this form versus what you did. Okay. All right. So to recap this problem, you're given a problem on a test, graph it. Once you graph it, try to pick out as many of the solutions as you can. We were able to pick out 2 of the 4, -5 and 0. We then use -5 and 0, and we use synthetic division to reduce the polynomial down to this, x squared minus 11x minus 6. From here, we try to factor it, but we discover sadly that we cannot factor it further. So we have to resort to either complete the square or the quadratic formula. So all of us should be able to use the quadratic formula and just plug and chug to get down to the last 2 solutions. And then we just write, well, all 4 roots. Fun stuff, right? Super fun. All right, let's try this one. Yeah, this one's pretty simple. Let me give you, I think 2 minutes should be more than enough to find all zeros for this problem. All right, 2 minutes, ready to go. All right, what are the 3 answers all of you got? No decimals. There you go. -1, 0, and 1/2. I'm sorry, I say 0, -1, +1, and 1/2. Looks like we had disagreement. So we got like a bunch of ±1, 1/2. We got -1, a half, and 0. Okay, so here's a so all of you graphed it, correct? All right, so everyone look at the graph. So I'm gonna kind of point out some stuff obvious. All right, does everyone agree that it crosses the x-axis at positive 1/2? Everyone see that? Yeah, okay. It passes at positive 1/2. Now, looking at your graph, does it cross the x-axis at positive 1? So we got a lot of no's. So if looking at the graph, if it does not cross the x-axis or touch it at positive 1, can positive 1 be a solution? Yeah, nope again, right? Nope again. So, do any of you want to retract their answer of saying 1 was a solution? All right, all right, all right. Now, I'm going to show the graph. So, everyone should have got this. So, it looks like, for whatever reason, a lot of you wanted to say plus or minus 1, but it only crosses or touches the x-axis at negative 1 and 1/2. So I think somebody in chat wrote down that it's negative 1 multiplicity 2, and I would agree with you. So negative 1 multiplicity 2, because it bounces, and then at positive 1/2. Now, did I need to do any type of like math, synthetic, quadratic, factoring to get these three answers? Yeah, I just needed to graph it, right? Yeah, now I could do, I'm going to show you the math just to verify this works, okay? So looks like we get negative 1. Now, this is kind of important to show because, so we do synthetic with negative 1, right? And that's what we get. But because it's a multiplicity of 2, we do synthetic division with negative 1 2 times because it's a multiplicity of 2. Negative 1 is a solution 2 times, so we can reduce it by negative 1 twice. So this is important to know that we can do this, because by reducing it by negative 1 2 times, we get down to 2x minus 1 equals 0. We can then set that equal to 0, and we can solve. So I set this equal to 0, I solve, and I get x equals 1/2. And this confirms my third 0 being 1/2, even though the graph clearly shows it's 0.5, which is 1/2. I wanted to show it this way. We also could have done synthetic division again for the third time with 1/2 to show that we get remainder 0. So another way we could have done it, right? So, the point of these is to show that every problem is different in its own respect. We're always going to graph these to see if we can pull out zeros. But we may or may not have to go further than that. Maybe they're, like in this case, 3 easy or 3 nice solutions. We can just kind of pull them out and be done with it. We may have to reduce the polynomial by the known zeros. And then from there, we could maybe factor it. We could do complete the square. We could do quadratic formula. There's different ways to approach these that all of you need to be comfortable doing and knowing what to do next. Let me see if I want to skip this one or not. No, let's do this one. Let's do number 3. All right, so I feel pretty confident after going through those first two that all of you should be able to work through this problem. So let's do 2 minutes again. Let's see if we can first find the first two zeros, and then I'll give you another 2 minutes to find the next two zeros without any help, okay? So 2 minutes for the first two zeros. All right, what did everyone get for their first two zeros? Plus or minus 3? I think we're all in agreement. So I'm just going to show you. So everyone should have had that, right? Everyone should have reduced it. We got down to 3x squared minus 2. So everyone should be to this point or further, right? All right. So I'll do another 2 minutes to find the remaining two zeros. Ooh, all right, everyone. What's the last two zeros? So plus or minus 2 square root 6 all over 6. Isaiah got plus or minus rad 6 over 3. Oh, okay. So you meant also rad 6 over 2. Okay. Oh, over 2, not 3. I think we got some disagreements here. Got some disagreements. So how did everyone solve for this? What did everyone do? Use the quadratic formula? That's one way to do it. If you like misery. Graphing wouldn't have told you anything. You just get decimals. All right, all right. Yeah, so you can't factor it, right? Yeah, factoring doesn't work. So it looks like the quadratic equation. Did anyone else use something differently than the quadratic formula? So Lizette says set it equal to 0, and I would agree. Yeah, set it equal to 0 and solve. That would have been faster. Would have been faster. Now the quadratic formula would have worked. But if you use the quadratic formula, so your A value would be 3, your B value is 0, and then your C value is -2. So if you did the quadratic formula, hopefully you had those. Yeah, so yeah, quadratic formula would have worked. Again, A being 3, B being 0, C being -2. If you did it right, you would have got the same answer. I just create more work for yourself. Yeah, so add 2 both sides, divide both sides by 3, square root both sides. All right, everyone doing good so far? So as another refresher, when you square root a fraction, it is the same thing as square rooting the numerator and denominator separately. And that's what I'm going to show you. So I rewrote it as rad 2 over rad 3. Now we can't stop here. We have to rationalize the denominator. So to get rid of, remember, we can't have radicals on the bottom portion of fractions ever in solutions. So we have to rationalize it. So we're going to multiply this fraction by rad 3 over rad 3. Another little reminder, review, that when you have a square root times a square root, you multiply what's inside together. So we would do 2 times 3 is 6 on top, and 3 times 3 is 9 on the bottom. The square root of 6 does not reduce further. So we have radical 6 on the top, and the square root of 9 is 3 on the bottom. So it looks like, I think Isaiah got it right. Yeah, he put rad 6 over 3. So I think Isaiah's the only one that actually wrote the correct answer. Oh, Brady did all. Well, Brady almost got it right. He put a 2 instead of a 3. All right, and then we just write the answers. So, the math from this point on, it's not difficult. It's just you probably haven't done it in a long time, right? We had to square root a fraction. We had to rewrite it as radical over radical, and then we had to rationalize it. And we rationalize it after we simplify this. And, rad 2 and rad 3 are already simplified. Yeah, so we rationalize it, we get this, and then simplifying radical 9 becomes 3. So there's your other 2 answers. Now, a way to check this, right? We could graph the original, right? And then you can type in radical 6 divided by 3. Type in radical 6 negative radical 6 divided by 3, and get the decimal equivalent to see if they match the graph, which I don't have this one graphed. So always verify your answers. Nice job, Isaiah. All right, how are we feeling about this one now? Now we went over some of those old concepts. So you're probably seeing how a lot of these questions, they're very different in how you approach them. It's like only 5 of you are still here. Yikes. All right, let's see what number 4 looks like. Now let's get number 4. I've already gone over time. Let me go ahead and just show the work for it, just so you can go back to the recording and see what we did. But pretty much the same as the last problem, right? And this way we get radical 14 over 2. So and we can write it either way, like that. So yeah, that was number 4, similar to number 3. There's the solutions again. I kind of want to just, these are just more review problems. Y-intercept, also really easy to find. Skipping those. All right, so this is kind of where we're at. We got to be able to graph this. So we're just kind of putting everything together. I'm just going to talk about them. I'm not going to do any of these, but like, here's the answers for number 17 and 18. We want to graph these, right? So if you're given a problem and the directions say graph it on your test or your quiz, you should go to Desmos and you should graph this. You should type this in to see if we can pull out any zeros. Well, if you can, great. So hopefully we can pull out all 3. If not, we have to pull out the ones that we do know, and then just like we've been doing today, we have to reduce the polynomial by those factors, and then from there try to factor it further, complete the square, quadratic formula, or just set it equal to 0 to solve the remaining zeros. So the graph part is just you taking all those zeros that you found and plotting them on the graph, plotting all your zeros, plotting your y-intercept, and then using behavior to sketch the graph, right? So this right here passes through. There's your y-intercept. It bounces here, so this is a multiplicity of 2, and then it goes up. So yeah, all of these you should be able from this point, seeing all those different examples is approach it that way. And then here's these last 2 examples. Again, graph them, pull out your zeros, reduce it, and then find the remaining zeros by quadratic formula, complete the square, factoring, or setting equal to 0, or whatever, right? And then plotting the point. So the graphing part should be easy once you actually know the zeros. That's why we spent more time on the actual calculating the zeros, because every problem is going to be different, right? All of these, they're similar, but they're very different on what we did, right? So I hope this this little review session helped, and that you learned a thing or two. Other than that, do any of you have any questions before we stop the recording? No? Well, thanks for coming, everyone. And as always, I hope you learned something, and I'll see you all tomorrow.